Hi, and we are on this paper at the moment, the practice set 5, paper 3H. Got the last two questions to do, nearly there. I think Millie's given up, cleared off around the corner somewhere. I'll try and get it in to come and say hello at the end. So, Nomus has 30 sweets, fruit, aniseed, and mint. Nomus is going to take 2 sweets at random, work out the probability that the 2 sweets will not be the same type of sweet. You must show all your workings. Probably the most successful way this is done is drawing a probability tree. However, more advanced mathematicians won't be reliant on it. But it's much easier for me to demonstrate what's going on if we do use a probability tree, and I would recommend using one in an exam. So first of all, taking the first sweet, 18 out of 30, 7 out of 30, and 5 out of 30. Double checking that all our branches add up to a whole one. Yes, they do, adds up to 30 out of 30. When we take the second sweet, it's all going to be out of 29 because we've already taken one of the sweets left, so there's only 29 left. So the top set of branches here presumes that I've taken a fruit sweet. So there's now one less fruit sweet in the bag. Presume it's all in a bag. So that gives me 17. The number of aniseed sweets will remain the same, and the number of mint sweets will remain the same. The middle set of branches here presume that I take an aniseed sweet. So the fruit sweets would have stayed the same as original. The aniseed sweets will drop by 1, and the mint sweets will stay the same. The last set of branches is mint, so the mint sweet will drop to 4, and the other ones will stay the same as the originals. Quick check, that adds up to 29, that adds up to 29, that adds up to 29. So it says it will not be the same type. So we want that one is no good, that one is good, that one is good, that one is good, that one's no good, that one's good, that one is good, that one is good, that one is no good. To work out the probability of each of these, I need to multiply them across, and then I need to add them all up because we want the various combinations. However, you can see I've got 1, 2, 3, 4, 5, 6 lots to add up, to multiply and then add up. Or I could use the rule that all the probabilities add up to 1. So rather than working out all of those 6, I could work out these 3 and subtract it from 1. So 18 over 30 times, I'm just typing it in my calculator, 17 over 29 is 51 over 145. 7 over 30 times 6 over 29 is 7 over 145, and the double mint, 5 over 30 times 4 over 29 is 2 over 87. Obviously these have been cancelled down on the calculator, and I've just got to add them together. Oops, I can't add fractions on a calculator. Let me go again. 2 over 87 plus 7 over 145 plus 51 over 145. So when I add them together, make sure you write down that that's what you've done. I get 184 over 438. Now remember, that's the probability of picking the same sweets. So I want the probability of everything else happening. So if I do 1 minus 184 over 435, I get 251 over 435. You can see it's not quite the same as the answer on my answer line, but it is just a simplified version of this. You don't need to cancel down your probabilities unless you're asked to in the exam. When you're working on a non-calculator paper and you're multiplying across, you just add your fractions together, but remember to add them properly. You need a common denominator to add them. So I'd be able to add those two, 58 over 145, but I couldn't apply the same rule here, so I couldn't just add those two and make 9. I'd have to make that out of 145 first before I added them together. So just watch out for that on a non-calculator paper. Also, probability always has to be less than 1, so double check your answer. If you've got something greater than 1, scrap and go again. Right, last question. As you can see, I've done it already, but I'll talk it through with you. So solve the inequality. Hopefully we should be really good at these. They were question 7 on those homework sheets that you absolutely adored. So multiplying out the bracket, 2x squared plus 3x is greater than 20. Pushing it all over to one side, making it equal to 0. We've got 2x squared plus 3x minus 20 is greater than 0. And then it's a quadratic, so we've got a couple of options on how to solve a quadratic. We can complete the square, factorise, or use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. The best way to do this one is to factorise. Because there's a 2 in front of the x squared, we can use the AC method, which you can see here. So I've done 2 times minus 20, which gives me minus 40. And I'm looking for numbers that could multiply together to give me this value. 1 and 40 is not going to do it. 2 and 20 is not going to do it. 4 and 10, but minus 5 and 8 is. The reason why that one's going to do it and the others aren't is because I need those numbers to multiply to minus 40, but to add to give me positive 3. So I've taken those numbers there because none of these have got a difference. They have to be one positive and one negative for me to get a minus answer when I multiply them. So I'm looking at the differences between these, and only minus 5 and 8, positive 8, is going to give me a plus 3. So I've got my quadratic here, and I've split my quadratic. I've split the middle term, so rather than writing the 3x, the plus 3x, I've written it as plus 8x minus 5x, and then the rest of the equation. So factorising the first part, I've taken out the 2x. Factorising the second part, I've taken out minus 5, which makes that a plus 4 in the bracket. And I'm always looking for getting those two brackets the same. Put these two together to form a bracket. There's my other bracket there. So this is what I've got. This gives me critical values from here of x equals minus 4. Don't forget I'm trying to make that bracket worth 0. And x equals 5 over 2. So I've drawn myself a little sketch of my quadratic. So I know it goes through minus 4 and it goes through 2.5. It's going to cut the y-axis on minus 20 because of that minus 20 there. And I'm looking for where this is greater than 0. Remember, this is your answer line. All between here and here, all my answers are less than 0. All the values that it's producing are less than 0. Okay? Here and here, all my answers, all my values that it's producing is greater than 0. So it's this section here that I want and this section here. If I've got two sections, it's going to be two inequalities. So I'm looking for where x is less than minus 4 and x is greater than 2.5. The rule is if you've got one space, it's one inequality, two spaces, two inequalities. That should help you write your inequality more easily. And that is the end of that paper there. Paper 3, set 5. Millie, Millie, come and say bye-bye. Millie, come on. There we go. Say bye-bye, Millie. Say bye-bye. She's looking a little bit traumatised. There's a good girl. Is it giving us a wave? Bye bye, Millie. Bye bye. Bye bye. Good girl.